Okay, now let's come to question 38. This is a question from the differential equations. It's a pretty simple question. We are given the function f, which is from 0, 1 to sort of real numbers, and this is the differential equation. This is the second order differential equation, and all we can do here is, if you look at it, we can just simply substitute df is equal to g, which that will be another function, and now we'll get a simple linear differential equation dg plus g is equal to 1, which can be easily solved by separating the variables. If you consider dg by dx plus g is equal to 1 and separate out g and x, you will get the function g is equal to 1 minus k into e raised to x, where k is the constant of integration. Just substitute g back into here and just integrate. Now f will be d inverse g. This is nothing but the integral of g, that is the so we'll get g of f of x is equal to x minus k into e raised to x plus c, and c is just the second constant of integration in the second step, and we're given with the initial conditions f of 1 is equal to f of 0 is equal to 0. Just substitute them. We'll get c is equal to k, and they're both equal to the value 1 over e minus 1, and so the final function that we'll get is x minus e raised to x minus 1 by e minus 1. Now, what we're asked with is the characteristics that of this function, the values that it takes over 0, 1. Well, you can check that this function has a unique global maximum that is between 0 and 1, and that can be obtained by first order and second order conditions. So the graph of this function will look something like this. This is negative, the function itself is negative for all x less than 0 and for all x greater than 0. So it will be less than 0 and for greater than 1 here, and it obtains a single maximum somewhere in between. So for all values between 0 and 1, this function takes non-negative values. That is the answer here. Coming to question 39, this question is from elementary arithmetic. What we're given with are n positive numbers, x1 to xn, and lambda 1 to lambda n non-negative numbers such that they add up to 1. And what's given in the question is essentially a weighted arithmetic mean and a weighted geometric mean, and we are asked the relationship between the values of those two. And if you know from our high school algebra, we always know that arithmetic mean is always greater than or equal to geometric mean, and this relation also holds in this case. Just to be sure, the easiest way to do is give the same value to all lambdas and same value to all x, then this will be equal. And if you take just two values, then if you take n is equal to 2, then this is indeed the true one. Lambda is equal to half and half, and x take some different values. So this is a pretty simple question, and the answer is the first option, that is this weighted arithmetic mean over here is strictly greater than or equal to the geometric mean. Okay, coming to question 40. In this question, we are given the set n, which is a set of natural numbers, and two arbitrary sets x and y, and we are told that there exists bijections between n and x and n and y. So these bijections represent nothing but sequences. If we consider the bijection to be f between x and n, then this bijection represents nothing but a sequence fn whose values are from x. Similarly, the sequence gn whose values are from y. Now, we are asked if there do exist bijections between n and x union y or x intersection y, or there is no such possibility of any bijection. Let's see if we can construct a bijection between n and x union y. Well, all we have to do is construct a new sequence whose odd indices take upon the value f from fn and whose even indices take upon the value of from gn. Thus, the new sequence constructed will have values from both x union y, which will indeed be a sequence, and thus a bijection from n and x union y. Now, although there might exist sequences from n and x intersection y, but that will not be the case always. Just take x and y which are mutually exclusive, that is, whose intersection is a null set. Thus, it's not the case that there will always exist bijections between n and x intersection y, but we can always construct, given x and y, bijection between n and x union y. Therefore, the correct option will be option 1, that is, there exists a bijection between n and x union y.